All right, what's going on, everybody? It's your boy Crypto Wolf back again for the most exciting video series that we even do on this channel. You know it is the PineScript tutorial. I know you've been waiting for it. I could feel the anticipation from here, but that's okay. You know what? It's getting a little better. We're getting through the language basics. Now this one's going to be a little bit more interesting than the previous one, but you know, if you are not necessarily into coding or programming, it may seem a little complicated at first, but it's really not that bad. It's just going to take a little bit of hands-on, and hopefully me explaining it in simple terms helps to get your mind wrapped around the general concepts. And if you are familiar with programming at all, then this should make pretty easy sense to you, and at least then you get an idea of what PineScript is capable of, what it consists of. But here we are over here. Let's see. No, I can't cover that. So once again, I have my little notes that I broke down from the actual longer and more in-depth tutorial, just to simplify things, add some pretty colors, all that good stuff. And over here on the right, you can see we do have the chart, and the green candles are pumping at the moment. So we'll see what's going on with that as we go. Money flow did get a little bump to the upside here just in the process of getting ready to record this video. So we'll see what happens. But this is part 3 of the PineScript tutorial, part 2 of the actual language videos here. Today we're going to be talking about, you know, conditional structures, which is like the if statements, and the switch statements, which is kind of a simplified if statement, if you will. And we're also going to get into the loops, you know, not the loop rings, not the fruity loops. Some of them might be a little bit fruity, but you know, the for and while loops. And this seems long, but it's not terrible. We'll get through it fairly quick. You know, a big chunk of this is one larger example of a more complicated script that I'm just going to breeze through. I won't go through every detail of it. Otherwise, this video will get a little bit long. But let's get into it. So, conditional structures are if and switch statements. Now, there are some built-in functions that cannot be called with conditional structures, such as input can be called within, but will be the same as a global input variable. If you're not familiar with that, basically it's just declaring a variable that is included in the little settings pop-up. So if you go and you want to change that value later on, how you can change moving averages on certain indicators, same principle. But if you were to declare an input variable, you know, within a local block, which if you don't watch the previous video, you better go watch it, because a lot of this shit ain't gonna make sense, just being honest with you. But a local block is basically, you know, a block of code within a larger function, or, you know, global block of code. Now, if you declare an input within a local block, it's going to act exactly the same as if you declared it in, you know, the outer or the higher level or the global block of code. So here we have just a quick little not example, but how it's broken down, how it's laid out. So you have your if, then an expression. So you say maybe if x is greater than y, then your local block is the code that is indented. So either a tab or 4 spaces, you know, under that, which is basically what's underneath that if statement. Then you can have an else if, you know, say you want, let's say if x is greater than y, else if x is less than or equal to y, then do such and such. And then else, maybe x is equal to, like equals, which is equal to, you know, y. And then you could have this little block. So the code will the script will do something different depending on how those statements work out. And it kind of branches off into a little logic tree. It's generally how they teach it in programming. And let's see. Oh, so if and else can only be called once. Else if can be called numerous times here in the middle. And again, it needs to be in the middle. Else is going to be your last one. and the expression must be a Boolean type or castable to a Boolean, and Boolean is true or false. So basically it has to be able to say if something is equal to true, then it comes down here and does the code in this block. If it's false, then it continues on to the next one. If it's true, does this code. If it's still false, comes down to this, and this is kind of like a catch-all for everything else. You know, it's a, you know, if this is true, do this, or if this is true, do this. For everything else, do this. And castable basically means that if you have, in this case, an integer or a float, you can say your integer is 1. You can have something that equals either 1 or 0. You can actually cast the 1 or the 0 to be true or false. And basically casting is just converting. Can use if statements to set values. And if you don't remember from the first one, this beginning part right here is basically a variable declaration. You have your declaration mode, the type, which is the, you know, is it a string? Is it an integer? Is it whatever? And then the ID is like the actual name of the variable. And then you can say, you know, variable is equal to, and then have your if and an expression from there. So you can kind of just combine things into single expressions and statements rather than declaring your variable up here, coming down here, you know, doing all the if statements, and then say, okay, the if comes out to such and such, go back and set whatever such and such is to the variable. So it's just makes life a little bit easier. But now you may have cases where, say you have a whole bunch of else ifs, and basically, you know, you have a bunch of options and you're trying to do something different depending on each option. A switch statement is a much cleaner and easier way to do that. It's, again, basically shorthand for successive if statements. And, you know, you can pretty much ignore this stuff at the beginning. It's the same for everything. So you can actually say, you know, variable equals switch, and then have your expressions, and then have your various blocks going on below that. Or, where we go? Oh, the lambda. Yeah, I'll get into the lambda here in a second, but it's easier just to show you the example here. But just looking at these little examples, the local block is to provide a return value if nothing evaluates to true, and it will return null, or NA, if nothing is executed. So you can do, like, at the very last statement, you could do a runtime.error and then give yourself a little error message that just says no matching case found. So if nothing evaluated to true, you won't just have it freeze up or take a crap on you, basically, and it'll come up with this error message. So at least you know what was going on rather than getting some nebulous error message. Yep, and then you want to add the float, and then in parentheses NA, which is basically null or not available. And it helps avoid compilation errors by setting that value at the end there. And when you start to look at a lot of other scripts, and particularly in like tutorials and things like that, you'll see these pop up here and there. It'll be like, you know, integer, NA, this and that. And it's basically just helping to avoid accidental errors, if you will. But here's the example. So, you know, you call switch, then you have your long condition. And the lambda is basically, to make life easier, just say is. So long condition is strategy.entry long IDs, your first parameter, strategy.long. Same thing on the short is strategy entry short ID, strategy.short. Or you can do, what the, is the or in there? I forget. It's been a minute since I looked at the switch. Float moving average equals switch MA type. Now, here's what I was talking about with your different options. So if whatever the type is, you know, has the text stored with it, if it's EMA, then it goes to, you know, ta.ema, close moving average length. Or if it's an SMA, goes and executes this. RMA executes this. And if it's not, it just keeps moving down the list, checking to see, does it match any of these, all the way down to WMA. And then if it doesn't match any of those, it comes down here to our little error message, just says no matching moving average type found. And then you got your little null float down here. Let's see, functions need to be executed prior to switch statement, as they wouldn't have a final value yet when evaluated. Oh, which is, whoops, oh, didn't mean to do that. You want to have, if you have any functions or basically anything that might be used anywhere in here, specifically, used in a switch statement, you want to have it take place prior to the switch, because it doesn't do calculations when it's looking into these. So you want to make sure that all the values are set prior to, seeing if it matches whatever you're looking for. Now you must match the local block types. And basically what that means is, anytime you're talking about types, that's your variable types, kind of like a file type, but in this case for variables. So x equals if close is greater than open, then close, else open. Both are float types, equals good. Bad example. X equals if close is greater than open, close, else parentheses open, which is a string. So one is a float, other is a string, equals bad, gonna give you a compilation error. If using conditional for its side effects, and you don't care about the return values, you're basically just using it as like a traffic cop deciding, which road to go down, which branch of the logic tree you want to go down, then you could do something like this, where if, bar state is last, if systeminfo.type is equal to crypto, line set XY, have your dimensions where you're setting the position of the line in the X and Y dimensions, and then set XY2, which would be your first point, your second point, catch your little null right there. Else, if it doesn't equal crypto, then come up with a label, say not a crypto market, and both returns are set to null at the end. And basically you're not trying to calculate or figure anything out. You're just saying, if it equals this, then put the line. If it doesn't, just throw a message that it isn't crypto in this case. If any of this doesn't necessarily make sense, throw a comment in the description. But basically, a switch is just a list of if statements condensed into just a real nice, easy one after the other. And you can have, in this case, it's just doing a function right after, but you can have more than this. You can basically, have some long expression, or even call up a separate function that you have somewhere else if you didn't want to try to jam it all in on like one line, even dropping down to multiple lines, which you can do. But again, it's basically your logic tree. If this go here, if this is true, do this, otherwise do this, and just keep going down the list until you've kind of covered the bases that might happen. Essentially, you want to try to cover all the eventualities, because if you're doing these if or switch statements and something comes up that you didn't account for, you're going to end up getting like a compilation error, and it's going to freeze up your indicator. So just take a moment to think like, all right, what are the potential outcomes that might happen while trying to make this decision? So moving on over here to loops. If you don't know what loops are, basically it is just doing the same calculation over and over again, incrementally for, say, maybe each candle or each bar. So keep in mind, you don't want to use loops When a built-in function already exists, these are faster to process and easier to code as well as to read. The built-ins are. Example, using a loop to plot a moving average by looping each bar to add it up and then divide by length, or by looping to count the number of up bars over time rather than using the math.sum function. So in other words, you know, if you manually explicitly go in and say, okay, take the close value of this one, add it to the close value of that one, add it to the close value of that one, add it to the close value of that one, and then divide by 4, and then use that to plot a line, is a lot more code than just using a moving average function, which is like one line. And you just tell it how far back to look and that you're using the close value. So not only is it easier on you, less typing, less complicated looking, but it's also processes a lot faster. Now, when to use loops. If you are manipulating arrays, which we touched on arrays in the previous video a little bit, and I'm not digging too deep into them yet because just going through, there's so much that revolves around arrays. I haven't decided yet, but it'd be worth its own video, even though it'd be a pretty damn boring video, I'll be honest with you. But if that's something that you want to dig into a little bit, let me know. I don't mind doing it. It's just, again, not exactly the most exciting. But looking back to analyze, when to use. Looking back to analyze bars using a reference that is only known on the current bar, like finding how many past highs are higher than the high of the current bar. That was a mouthful, right? But basically, we'll get to that in a second. But also performing calculations that can't be done with built-in functions. Because let's face it, I mean, they don't have them for every single thing that you could possibly think of. Now, you have the two different kinds of loops. You have a for loop and a while loop. I know there are other types and other structures in various programming languages, but in the case of what you'd be doing here, there's not a big need for anything else. Now, a for loop performs repetitive statements using a counter. So you're going to have like an index variable that's going to increment each time you run through the loop. So think, you run to the bottom. All right, so your index is now 2. Run through it. Now it's 3. Run through it. Now it's 4. And it just does that until you reach whatever number you want to stop it at. So setup is you can do, if it's in the square brackets, it's optional. You can do an identifier equals and then have the for loop, or you could just say for identifier equals expression 2. And then you can also do by, which is the increment by. And then you got your local block. So identifier variable's name. The initial one in brackets there is optional if you're using loop within value setting. Now for identifier is the initial value, is that index number that we're talking about, the index variable. Equals expression is the start value. So what, are you starting with? 2 is going to be the end value naturally. And then by is the step that the counter increases or decreases, each loop, each time you go through it. If you can leave out the by and it'll just default to 1. Or if you're doing, depending on the math that you're doing, it could be -1. But here's our little example. So remember, start off with your version. Then you got your indicator. You could have indicator, strategy, or library. Mainly be sticking an indicator, and it's going to be called for loop. That's the actual title of it. Now, look back input equals, so you declared your variable with the name right there. Input.integer, so it's going to be an integer. It'll show up in the little settings pop up, and you could change it. 50 is going to be the default value. Then look back in bars is what it's going to say next to that little text box. Minimum value 1, maximum 49.99. Higher bars set equal to 0, lower bars set equal to 0. Here we go. If bar state is last, so then it's, as long as that's true, we'll do everything below it. Var label LBL, which is just short name for label, equals label new, you know, NA blank string style label left, and it's just creating the label. So each time, you know, this whole thing runs, as long as that's true, it'll create a label. Now get into our loop. So for I equals 1, so I is our little index variable. 2, look back input. If you remember, we created it up here. So default value is 50. So let's just say I equals 1 to 50. So as long as, you know, we go through this, it'll do it 50 times, unless you change it. I mean, specifically, unless you change like I manually. But so if high, remember in the square brackets right here is like an index position of the bars or candles. So let's just say it's equal to 1. So the high of number 1, which is going to be 1 back from the current. If that's greater than high, which is going to be the current high itself, then higher bars plus equals 1. If you don't know what that is, basically it's just a shorter way of saying add 1 to the variable higher bars. So it's like saying higher bars is equal to higher bars plus 1. Much shorter way to type it. Else, if high 1 is less than the current high, then add 1 to lower bars. And basically it's just counting, you know, how many higher or lower bars from the current that you have going back 50 positions. And then down here you just have label set position, label set text, and you're going to take your variable higher bars as your first parameter. And then in quotes here you have your little string, which is just going to say number higher bars. The /n is going to be new line. And then on your next line it'll be lower bars and number lower bars. And so each time it goes through this, you know, until it gets to, so right here is going to be the local block. So as it'll get through this, and then it'll see what the tab spacing is on this, and it'll say, well, okay, that's no longer local. It'll come back up, restart the loop again, and it'll keep going until I is equal to whatever that variable is right there, which if you left it at default would be 50. And once that is, you know, once it reaches that, it'll just continue on and it won't run it again. And so this one, the harder example is, as you can see, much longer script. If you want, I'm also going to leave the link to the tutorial, the official TradingView PineScript tutorial. I'll leave that in the description. You can find this in there in the loops section. I'm also going to leave a link to my little notes right here in case you don't want to read the long version. And it's in here. You can literally just copy paste it, you know, right here into the Pine editor. But just real quick, take a look here. So up here, you're just establishing, initializing your variables up there. Q is a new element in an array. DQ is the first element. So basically it's just creating an array, creating a new element within the array, and checking to make sure that, you know, we have a set number of elements we're allowing in that array, and making sure that it didn't reach capacity. If it did, get rid of the oldest one and shift everything down kind of deal. Then here, loop through an array of lines, extending those that the price has not crossed or deleting those. This program, I forgot, I should probably explain what the hell it's doing, is an example, uses a loop in its check lines for breaches function to go through an array of pivot lines and delete them when price crosses them. A loop is necessary here because all the lines in each of the high pivot lines and low pivot lines arrays must be checked on each other, and there is no built-in that can do that. So basically you're just creating pivot lines, and every time the price breaks through that pivot line, it says, okay, it cuts it, it stops extending it, and it goes on to create a new one. A little bit more than that too, but that's the gist of it. So up here, so we have a for loop here. So it's saying for line number is equal to 0, 2, and then you have an expression in parentheses here within the, you know, the upper limit of the for loop, quantity of lines greater than 0. And then if you don't remember the ternary statements, go watch the previous video to explain it. But basically it's just saying quantity of lines greater than 0. Is it? If true, quantity of lines minus 1. If false, then set it to null. And then you're going to do everything in here each time you loop around. I'm not going to read through everything. It's a whole bunch of happy horse stuff. And even down here, you got some if statements. You know, if not null is basically what that's saying. So it's saying if high pivot is not null, you know, do these lines. Else if low pivot's not null, do these lines. Now, if they were null, it's just going to skip over that whole section. And then you just have these functions down here at the bottom. Check lines for breaches. You're going to check your high pivots, check your low pivots. Moving on. So, where are we at? 25 minutes. Damn, I'm trying to keep it short. So then you have the while loop. So basically, a while loop allows repetitive execution of statements while a condition is still true. The setup, again, if you want it, you could have the variable equals at the beginning or just while such and such, and then have your local block. I broke it. And basically it's just saying the while expression evaluates to true, the loop continues, and it stops whenever it reaches false, whenever it equals false. So example, while I is less than or equal to look back input, you know, if high, let's call it 1, is greater than the current high, higher bars plus equal 1. Else if high number 1 is less than the current high, lower bars add 1. And then the one thing you got to remember about the while loops is that you have to manually set the counter at the end. So in this case, I plus equals 1. So we're basically just adding 1 to I. So now I equals 2. If it's less than or equal to whatever the whatever the input variable was that you'd set further up in the code. And you get the picture. Just keeps going until, you know, I is less than or equal to. And to reiterate, you know, the counter must be incremented manually inside the local block as well. You know, you don't want to come back here and, you know, start a whole fresh new line outside of this while block to increment it, because it'll never see it within the loop. Also, again, yeah, value plus equals 1 is the same as value is equal to value plus 1. And also remember from the previous video, if you're ever resetting, the highlight's terrible. If you ever have to reset a variable after it's already been established, you got to use this little semicolon equals. Because something weird PineScript does, it's just, you can't necessarily just, you know, if I say value is equal to 1 up here, and then down here I say value is equal to 2, it's going to throw an error. And last example here, you know, factorial parameters, integer, you know, basically establishing just another integer variable, you know, int val equals null, so just a null integer. Lambda, which basically just says is, and it's saying that, you know, this is equal to the result of all that. So counter equals val, which we established up here. Integer fact equals 1, while counter is greater than 0. You know, reset fact to fact times counter, reset counter to counter minus 1. And then this is the return value for this function. If it doesn't make sense, don't worry about it too much yet. We're just kind of going over the basics. I don't want to get into like too much detail, because you could spend plenty of time on any one little thing. And we'll do a little bit more of that when we actually come to like going through some examples down here. And we'll actually, you know, make some indicators, and we'll play around with stuff, adjust things here and there, and you can see what it does in real time. And I think that will be a better place to, you know, dig into the weeds a little bit. And if enough people are interested in it, I know I've heard a little bit of interest so far. But if enough people are, we can always do, live streams of it, and you guys could ask me questions in live time. So let me know if that's something you'd be interested in. And beyond that, I think I'm going to cut this video off at this point. I don't necessarily want to do too much of the chart analysis on this one. I'm going to leave it strictly with the PineScript for now. So if it's helpful to anybody looking back in future times, I hope you enjoyed it. I hope it was a little bit helpful. And if you have any questions, let me know. And we'll see you on the next one. And on and on and on.